So guys, are we live? Uh, Let me check. Hi, let me just check. Do voice is clear or not? So guys, do voice is clear? Hello? Yep. Now it's clear. I can check. So yeah guys, let's start. So today let's start. Let's first get into this daily question first. Let's go then. First, let's practice this daily question first. Okay, so this question is solved once, but let's solve it again. Let's make the intuition from the beginning and solve it. So it's the find the smallest letter greater than target. Okay, let's read. First of all, let's read this problem statement that you are given an array of characters, letters that is sorted in non-decreasing order and a character target. There are at least two different characters in letters. Okay, written the smallest character in letters that is lexicographically greater than target. Such a character does not exist. Return first character in letters. Okay, so let's dry run it first. Hmm. The letters is CFJ, like letters array C, F, J, and the target is A. Target is A. So I have got an idea. Like first intuition which comes into my mind is this target. We can place this target in the letters and sort it. But if when I do this, I will lose track. Like how I will get that which character or target which I have put into the letters. So this approach may not work. Um, so we have to think it in different way. We have to get like we are given this target A, and this is the array provided. So what we have to do, we have to return the smallest character in letters which is lexicographically greater than A. Okay. So C, D, F, J, and the target equals to A. There are no characters in the letters that is lexicographically greater than this. So we return letters J. So we can first initialize an answer. Answer can be initialized with the first letter C. I have to check whether it's if it is smaller, then only we can change, and greater. I think I can do it in order of n, like in a single pass. Okay. Yeah, I have just initializes first the answer equals to first letter of the array. So in this example, I got C. So I will check whether it is smaller than the previous one, like the initialized one, uh, and greater than A. So yeah, first my pointer will be at F. So I will check whether F is smaller than F. Smaller than F? No. So we don't compare it with A. Then I checked with J. Do it is smaller than J? No. So the answer will be C. But it's greater than A, right? Okay, this condition I forgot. Let's dry run this another one. Like CFJ, EFJ, and target is C. So I have answer equals to C. Do C is greater than C? No. Then do do F is greater than C? Yes. I got a confusion here. Actually, I'm not getting this like a dry run. Let's do it again. Let's try it. Letters given C, F, J, and the target equals to A. We have to return the smallest letter. Smallest. We have to smallest character in letters, but that character has to be lexicographically greater than the target. So first, one thing which comes into mind is that let's sort it first. So sorting C, F, J already sorted. Target equals to A. Yeah. So 2 C is greater than A. Yes. So the answer will be C. When we okay, we got it. Let's solve it. First sort it. Char answer equals to letters first character. In case we didn't find any, then sort it first. Letters dot begin, letters dot end. The array is sorted like for I. Let's run. Let's traverse the array. I is equal to 0. I less than letters dot size I plus. We have to check if letters I greater than target, then that is equal to letters I. We have to just return the answer here. The only return letters I, right? If we didn't get anything, then we have to return what? Return answer. Let's see if it works or not. It's working here. Let's submit it. Okay, so this works, but uh, the time complexity will be order of n times log n, right? And then this loop will take order of n. So that final time final time complexity we got is order of n log n, right? Yep. So we got this. Can we solve it in order of n? Can we solve it? Can we solve it in order of n? Let's try. Let's take this example 2. This thing is solved. Okay, that letters given is C, F, J, and the target equals to C. Basically, we have to get a character which is lexicographically greater than C, but uh, smaller, but smallest in this, like smallest in this array. We have to maintain two things. Is it smallest in the array and uh, and greater than C? So what we can do? We can first initialize answer equals to first character. So we have initialized it with C. Now we move. Now we are moving. 2f is smallest. 2f is smallest in C. Sorry. 2f is smaller than this previous initialized. No. Okay. And something I'm not getting. I want to solve it in order of n. I need to traverse it only once, and I have to maintain some properties like it's smallest in the letters among these letters and lexicographically greater than A. That target. The target is C. The second example. I'm trying to figure it out. Okay. Mm, that simple approach was like sorting this array and checking. How can we do it? Okay. I want to solve it in order of n. What to do? Like let's think. Suppose if I got stuck there like this, at that time it will be hectic. This practice is necessary, right? This questions. Sometimes this easiest question can make us think. Sometimes we complicate things, but actually the things are not that much complicated. I think I'm just thinking in a very complicated way. What can I do? It I have to like maintain two things. Like I can maintain one minimum. I am thinking about it. Like I can maintain two things, like minimum and lexico greater. I can maintain a pair. Yeah, like something flag like thing, which is a pair which contains that minimum, like smallest one, and a flag like it that the previous smallest one was greater or not. So flag. First, when I came to C, I have given that is it like minimum C, is it greater than C? No. So I have put it into false. Then my pointer moves to F. Now do like do F is greater than C? Yes. And do F is greater than C? Can like move it like F and true. Yes. Now when I found something like it is lexicographically greater than the target as well as it is uh, uh, when I found something minimal and as well as it is greater than the target, then I will only update it if I found another one like it is greater than the target and smaller than that previous minimal element. Can I do like this? Can I simulate this one? Okay. Yes. Let's do it if we can simulate this one. So where char comma pool track thing which I'm using here is like a pair. It will be character. It will represent the minimal character, true or false. Right. Let's traverse it for int 0 I less than letters dot size I plus plus. I have to initialize it with the first character. I think am I track dot in character is as if that first character letter letter target true otherwise false. I think this works because I'm not sure about this syntax. So okay, I'll figure out this later. That first thing is actually given, so I will start with in pair. How do I access it? That first and second. If letters I, if letters I less than, less than track first and dot can equal false. Am I checking the correct condition? Wait, let me try run it first again because it's causing a lot of confusion. Okay, I have initialized like C and false. Wait. First of all, let me check if dot first. Greater letters I, it means I have got the letters I. Then if track dot also check it like then only we can dot I true. If track dot first we have got that smallest one, then if track dot second like track dot. So I have got the thing dot dot I think this approach is going to return track. I need to check that. Let me check. Let me check that first. Uh, Let me check first. Why day 2 is 2 days later? Hmm. Like I was too busy. Actually, my college has started now, so that's why I got a couple of things. But now I have settled the things, so I'll be coming live daily. So next time, I think it's not going to be repeated. What I was checking, yeah, that syntax of inserting into the pair. Syntax of inserting in pair. Need to insert thing. Yeah, we can use that pushback thing. Can we use it here? Let's check it. 'Kay, now I got an error here. Track.pushback letters. Oh shit. It's not liters first. Then what? Not pushback. 1 minute. OMG. So I have made it here a blunder. I didn't see this. Like it is given, it is sorted in non-decreasing order. So uh, that first approach which I have tried, that was like of sorting that array is of no use because it is already sorted in non-decreasing order. So it is the question of the binary search. See that one mistake which would have costed me everything. I'm not reading the question properly, or sometimes not paying attention to the details here. Okay, so let's apply the binary search. So we can solve it in order of log n. Okay, so int left equals to 0, comma low or high. We can int low equals to comma high equals to letters dot size. This one we can apply this binary search. Let's initialize this answer as well. Yeah, character answer equals to letter 0, non-decreasing. Like it's sorted in ascending order. Okay, let's while low less than equals to high equal. Okay, this 10 raised to the power 4 the length. Second, that binary search condition, which I forgot. Letter so if letters of mid is greater than target or equals to letters mid. So I have to like eliminate which which search space at high is equal to mid minus 1 else if else else low equal to mid plus 1, right? The simplest one, alright. Think something. Okay, this thing is solved. Okay, so this question is solved finally. So guys, what I learned today, like I have to take care of the constraints and read the question carefully. Like I have missed this hint, small hint. It is already sorted, so no need to sort. It was just a binary search. So here comes one pattern. Here, like I got one pattern in my mind that if the arrays is sorted, like if any array is sorted and we have to find something or like filter out something, we can think of that a binary search thing. So this thing is clear, and this question is also can see uh, it almost took 47 minutes, around 40 minutes to solve this question. Like it's the easier question. So uh, I would have solved it in 20 to 25 minutes, but it took around 40 minutes. So it was my mistake that I didn't read this question. So we can like keep in mind like to read this question very carefully. I read 2 to 3 times. At first, I was not getting the question, like the intuition was not getting clear in my mind. But that sorting approach, no need to sort that thing because this it was already sorted and I didn't read this, so it took my 20 minutes time. Otherwise, it would have been solved in like how much time it took to write this 7 to 8 lines? Hardly 5 minutes. So it would have been solved in 5 to 10 minutes, and but it took 40 minutes. So yeah, we can learn something like to read this question. Okay, so now the daily question problem is over, so we can move to trees. So that day we have done those basic traversal problems. So today we will move to some standard problems, revising some standard problems and these. Okay, so as you know, I am following this driver sheet. So I'll be opening that thing and opening that driver sheet. That day we have done this introduction in order, post order, level order. So today we have to move to the medium problems. It's already solved, but I need to revise some. Yeah, let's reset this code, and it is at LeetCode as well. So let's search that LeetCode maximum depth problem in LeetCode. It's also considered easy, but when I read it first, when I solved this first, uh, it was like something like I considered it as hard. So it is asked, see, it has asked in various companies: Amazon, Apple, Microsoft, Google, SAP. See, now you can like uh you can get the intuition like how much like this question is so much important. Okay, so I will be first dry running it from the scratch, and then I will come to coding. So I have got here my screen. See, I dry run these things here in the screen. So here given the root of the binary tree, return its maximum depth. The first raw or the brute force approach will be like I'll be going into every node and calculating the height of left subtree and right subtree, and then uh, maintaining a max variable to calculate the maximum depth. So let's read this question. Given the root of the binary tree, return its maximum depth. A binary tree's maximum depth is the number of nodes along the longest path from root node down to the farthest leaf node. 1 2 3 1 2 3. So this like we can just construct a function of get height. We can get the left subtree and right subtree. Okay, so how the algorithm will run, let me see. 3 20 and 7. So we'll be using a function, private function height. We will pass root. We have to design a function get height, and then okay, let's write this main function here. Maximum depth. See, sometimes not revising can make you stuck even on the easiest questions. Here I am stuck a bit. We have function, another function. We have to make another function get height. max depth, get max depth. First of all, we are just following the raw brute force approach.